Good morning, everyone. So I will proceed to the presentation of my project entitled Controlling Greening in Potatoes, which aims first to understand the major risk factors, the major causes of greening in potatoes, and then to be able to test and to develop different strategies allowing the reduction of green potatoes in stores. So many people, when they see normally green potatoes, they think about toxic potatoes or potatoes that are unsafe to eat. So what is a green potato? Is it really toxic? And what are the main causes of greening? So in fact, when potatoes get exposed to light, they start to accumulate chlorophyll. Chlorophyll is a natural photosynthetic pigment. We can find it in all plants, and it's even completely safe to eat. However, the accumulation of chlorophyll in potatoes can lead to that green discoloration that we can see on the tuber surface. And this will lead consequently to consumer rejection. So from where this toxicity comes from, actually light can also induce a glycoalkaloid synthesis. And glycoalkaloids are, yes, known to be toxic compounds if they were consumed at higher concentration, which is not normally the case of the light green potato that we can see in the supermarket. I should note here that greening or chlorophyll synthesis and glycoalkaloid synthesis are two independent biochemical processes. So for example, we can find a high green potato, but that does not necessarily mean that it is high glycoalkaloid content as well. So both of them are independent, but are both induced after light exposure and can both lead to loss of potato marketability. So what are the main causes of greening? Again, light is the main primary factor that can induce greening. And light exposure can occur throughout the whole potato food chain, from farm to fork. It can occur in the field, for example, due to maybe insufficient hilling, insufficient planting depths, or maybe to wind on light soils. It can occur during storage, during transport. It can occur as well in the packing shed if the process was not really quick. And obviously it can occur in the supermarket and on store shelves. Other factors can affect chlorophyll synthesis. I've grouped these factors into pre- and post-harvest factors. The pre-harvest factors include, again, the planting conditions, like planting depth, soil coverage, soil type, and fertilization. We have previous evidence that increasing soil nitrogen rate can also increase greening rates. The maturity stage of potato at harvest. Varieties. We have significant differences between varieties in their greening susceptibility, and I will be talking further about that in my presentation. While the post-harvest factors can include storage conditions, like lighting conditions, like temperature, O2 CO2 levels, and the duration of storage. So, how potatoes can turn green? We know that potato tubers are organs filled with starch, filled with amyloplasts in which starch can accumulate. So when these potatoes or when these amyloplasts get exposed to light, the amyloplasts will get converted into chloroplasts in which chlorophyll can accumulate. So to resume, this conversion from amyloplasts to chloroplasts under light exposure is responsible of the greening process in potatoes. I've added this slide to show that greening is really a quick process. So I've chosen here a variety with average susceptibility to greening, and the tubers were exposed to fluorescent light with 24 hours photo period. So before any light exposure, we can see that the cells don't have any chloroplasts, any chlorophyll. After 2 days of light exposure, we can start to see few chloroplasts in the cells. However, the green color was not really visible on the surface. Day 3, day 4, day 5, the number of chloroplasts started to increase. And in day 5, we can see that the potato was completely green and completely unmarketable. Therefore, avoiding light exposure is highly recommended because, as we can see, few days of light exposure can induce greening and can consequently lead to a loss of potato marketability. How to control greening in potatoes? Obviously, the best solution is to use resistant varieties, varieties that can resist as much as possible to greening. We can control storage conditions, we can control light, we can control temperature and O2 CO2 levels, and various post-harvest practices have been already tested, like coating, for example, coating with waxes, coating with oils, coating with chemicals. All these strategies have been shown to be effective, and packaging or the type of packaging used. So many strategies have been already tested and shown to be effective. However, the goal is to choose the solution that can accommodate industry needs and that can improve greening without affecting other quality attributes in potatoes. Display practices in retail stores can matter. So the distance between the light source and potatoes can matter. The intensity of light used in the stores can matter. And the light spectrum, because in the end, chlorophyll synthesis is a function of the absorbed wavelengths. So the type of light used in the supermarket can affect greening. We know, for example, that using green light is better than using red or blue light. Packaging material can also matter. So it depends if potatoes are kept loose, without any packaging, fully exposed to light, or if they were packed. And if they were packed, what is the kind of packaging material? Is it transparent bags, where also potatoes are fully exposed to light? Or is it brown or colored bags? Or is it modified packaging bags? So all these practices can matter. The first objective that I have been working on lately is a varietal screening. So I've screened 92 potato varieties for their greening susceptibility. So all these varieties were grown under controlled growing conditions. The tubers were exposed to 5 days fluorescent light, 24 hours photoperiod. The photosynthetic photon flux density was of 12 micromole per second per meter square, which we expect to have the same more or less in retail stores. For each variety, I had 3 biological and 3 technical reps. And for greening evaluation, I've evaluated the color, the change in color, and the chlorophyll synthesis. So here we've compared the color of potatoes in day 1 and in day 5 after 5 days of light exposure. And as we can see, when we look at the lightness value in day 1 and the lightness value in day 5, we can see that all potatoes change their colors. All potatoes become, almost all, become darker after light exposure. However, we can see differences between varieties. So the color change can be more visible in some varieties and less in others. And the same here. So when we extracted chlorophyll and we measured chlorophyll content in these varieties, so we can see also that we have significant differences in greening levels. Some of the varieties after 5 days are having 1 milligram per liter of chlorophyll, while others reach 9 milligram per liter. So greening tendency significantly vary between cultivars. And what does that mean? So these potatoes with low chlorophyll accumulation can be a good source of resistance to greening. So planting these varieties and even introducing these varieties into various breeding programs can be beneficial towards the development of greening resistant varieties. Second, comparing these resistant and susceptible varieties will allow us to understand what causes the resistance to greening in potatoes. So is it related with potato pigmentation and their absorption properties, or is it related with skin properties like skin sickness, or is it related with skin permeability, gas exchange, and metabolic rate? So in other words, what are the genetic differences between these resistant and susceptible varieties that can explain these results? Is greening tendency correlated with skin color? So in a preliminary analysis, we checked chlorophyll content in different varieties with different skin color. So as we can see in purple, red, and pink, we have slightly less chlorophyll content than in white varieties, for example. But however, more work should be done to check whether we have any correlation between greening and skin color. And when I speak about skin color, I mean potato pigments that we can find in the skin, since each of these pigments has different absorption spectrum and different ability to harvest light. From a consumer point of view, a consumer can go to the supermarket. He can see a red or russet variety which is highly exposed to light, it can be green, but he will not be able to notice that because the color will hide. So he can still buy it. While this is not the case for yellow and white variety, because the green color will be directly visible for these varieties and they can quickly lose their marketability. The second objective that I have been working on is to analyze greening incidence along the production chain. So what are the causes of greening along this production chain? So in this graph, we can see a preliminary analysis as well of 3 years data that we got from Zarella Fresh regarding greening losses at harvest. So we can see that in May, June, July, we have higher greening losses than in Jan, Feb, and March. So the next step will be first to make sure that these variations are due to seasonal variations and not to any other reasons, like maybe different growing location or different soil type. And in case these variations were seasonal variations, we will aim to understand what can cause that. While the third objective is to analyze greening incidence in retail stores. So we already know that Woolworths keep records of their potato rejection rates. We already requested this data and we are looking forward to get it if possible. So with this data, we will aim to identify seasonal, varietal, and regional trends. We will aim then to examine individual Woolworths stores, so stores with highest greening rates and stores with lowest greening rates, to be able to understand more what are the greening driving factors. What I will be doing in the next couple of months, so first, as I mentioned before, by comparing these resistant and susceptible variety, I will aim to understand the basis of resistance to greening in potatoes. So I will aim to examine the structural and metabolic change after a light exposure, as well as the expression of various candidate genes related with chlorophyll synthesis in potato. As well, I will aim to identify key factors of greening along the production and retail chain, and test various packaging type with the aim to reduce greening. And with this, I would like to finish my presentation. Thank you all for listening. Big thanks to our industry partners, Woolworths and Zarella. And the final thanks is for my supervisors and all the ARC team. Thank you.